All right, welcome back, everybody. This is the first day of the new book. Let's go. Exciting, right? This is section 1.1, solving simple equations. All right. So the first chapter out of this new book is like, boom, start off with solving equations. This first section is just solving simple equations, meaning just add, subtract, multiply, and divide. One operation to solve. That's it, okay? So let's remind ourselves what an equation by definition really is. An equation is a statement that two expressions are equivalent to one another. An equation is a statement that two expressions are equal. And again, you're filling in the blanks here. A statement that two expressions are equal. I've got two expressions, one on either side, and I say they are equal to one another. The second thing, a solution to that equation is basically a one value that makes that equation a true statement. So if I've got an equation, say 2x is 8, 2x is equal to 8, 4 would be my solution, because if I took 4 in place of x, 2 times 4 would get us to 8. So the solution is any value that makes that equation a true statement. We're going to talk about equivalent equations, one where equations have the same solution. When you perform the same operation on each side, of an equation, you produce an equivalent equation. Basically meaning, whatever you do to one side, you must do to the other side in any equation. Whatever you do to one side, you must do to the other. Let me repeat that. Whatever you do to one side of the equation, you must do to the other side of the equation. Now, we're going to have some rules to follow in terms of addition, subtraction, multiplication, and division. Okay? Here's our key idea for solving addition and subtraction equations. Remember that inverse operations will solve an equation. So if I've got 2 or x plus 2, I have plus 2 sitting out there with x. I subtract 2 over to the other side to solve my equation. Remember, inverse operations will solve the equation. If I'm doing addition, I've got to undo it with subtraction. If I'm doing subtraction, I undo it with addition. So let's practice some. Solve the equation, and then we are going to check for these first couple. Now, it's going to be very important that you do these equations, that you do these equations exactly how I'm going to do them. Okay? I'm going to require you to do the work exactly as you see it on the board with me. So, what operation gets x alone? What operation gets x alone?
Subtraction?
Well, it's already being subtracted. So what do I do to undo it? Addition, right? So here's how I want you to show it. I want you to show the operation that you're doing underneath it to both sides of the equation. Heck, if you even want to put a dotted line down the center of the equal sign, if that helps you, do it. Because remember, you got to put the operation on one side and the other. Whatever I do to the left side, I must do to the right side as well. Do a horizontal line underneath, and then do that operation on each side. Like, what happens when I take negative 3 plus 3? It cancels out, right? Leaving me with just the x on the left side. What happens on the right side? What is negative 5 plus 3? And that's my answer. That's my solution to the equation. X equals negative 2 is my solution. Now, how do you check a solution? How do you check a solution? Go ahead. Very good. You take the negative 2 and you plug it right back into the equation. So negative 2 minus 3. Does that truly equal negative 5? Yeah. Negative 2 minus 3 does truly equal negative 5. That checks out. I know for sure x equals negative 2 is a solution to my equation. I love solving equations problems because you can always check your answer. You can always check your answer, which is awesome. So let's do it again. What do I do to get y alone? What do I do to get y completely alone on the right side? Gio?
Plus, or,
It's already being added, so what do I do?
So subtract 2.8.
Exactly. I subtract 2.8 from each side of the equation. I subtract 2.8. You're going to see me. I don't usually draw that dotted line in down the middle. You can if you want to, but you're going to see me write it like this more often. Now I'm going to go to my calculator. I don't know 0.9 minus 2.8 on the top of my head. Negative 1.9 is equal to y. Yeah.
I did a different way, but I still got the answer.
What'd you do?
I subtracted 0.9 from both sides and still got the answer.
Be careful with that. You never want to move all things to one side of the equation. That might screw you up when we have multiple steps. Okay? So we got y is equal to negative 1.9. Remember, this is the same thing as saying y is equal to negative 1.9. Left, right, doesn't matter. And if you wanted to check, again, you could check it by saying, okay, 0.9 is equal to negative 1.9 plus 2.8. Is that a true statement? Let's check it. Negative 1.9 plus 2.8. Is that 0.9? Yeah, that does check out. That does check out. Good. Cool. Let's practice some more. Okay. Yes. Oh, yes. Okay, so what do we do for example 1 here?
You'll subtract 3 from 3 and then subtract 3 from -10.
Good. And what does that get us?
-1. No.
Your second guess.
10.
Negative 10. Good. Negative 10. It's tempting to say negative 4, right?
Mm-hmm.
Tempting. So that would be negative 7 plus 3. Good. Does everybody see how I'm setting it up like that? That's the way I want to see it. So on your homework tonight, when you go to do number 2, write the original problem. Do the inverse operation. Horizontal line, answer. Original problem. Inverse operation. Horizontal line, answer.
Do you want us to write the answers to our homework like on a notebook piece of paper?
Put everything on a notebook piece of paper. You don't have to put just your answers on a separate thing. I want all your work and answers on the same sheet.
Oh, okay. So
That
you
makes
want us to do like number 2, here's our work
Yeah.
answer kind of thing?
Yeah, everybody take a look. So if I'm doing my homework, here's my page, here's my notebook paper, right? I'm going to say, okay, here's number 2. Like if number 2 was our number 2, I'm going to write g minus 1/3 is equal to negative 2/3. And then I'm going to show the next line. And then I'm going to show the answer. And then I'm going to move on to number 3 or number 4.
Yeah.
Does that make sense?
Yeah, I got you.
So let's do number 2. What operation gets G completely alone? What operation gets G completely alone? Oh, Noah?
Yeah.
Right? Noah.
You can add it.
Add what?
1/3.
Good. I'm going to add 1/3 to both sides. Now, you're going to need to rely on your calculator a little bit if you don't know these fraction problems, but that's okay. If you want to use your ABC button, if you want to use the fraction button, that's fine. If you want to use the division sign, that's good too. You're going to see me have to write it like this because I don't have your calculator on my screen. Here's how I have to write it. Negative 2/3 plus 1 divided by 3. See that? That's how I have to write it. And now you have your F to D button. I have to go in here and hit answer. Negative 1/3. G is equal to negative 1/3. Somebody asked me last period, can I put it as a decimal? It depends. Is the problem given to us in fraction form?
Yes.
Yes.
Yes, so I want it back in fraction form. Don't give me decimals when I gave you a fraction. The next problem, did I give you decimals? Yeah, so it's totally fine to give me back a decimal. You don't need to do a fraction. What solves this next one? What do I do here?
Subtraction?
Subtract what?
The 3.9.
Good. I subtract the 3.9. Remember, we're always looking to get things away from our variable. Move things away from our variable. All right. And then we have negative 6.5 minus 3.9. Let's see. Negative 6.5 minus 3.9 gets us negative 10.4. That's my p-value. If you're ever questioning yourself, plug it back in. If you're ever questioning yourself, just plug it back in and see if it worked or not. So that's addition and subtraction. Let's talk about multiplication and division. Remember, the inverse operation of multiplication is division. Inverse of division is multiplication. And whatever I do to one side, I've got to do to the other. So let's do the same thing. Now, this is a little bit tricky. This is a little bit tricky here. I've got n divided by 5, but it's a negative there. It's equal to negative 3. I've got n divided by 5, negative on the left side, is equal to negative 3. What operation gets n along? Oh, gosh. Oh, darn it. I'm going to have to look at my seating chart. Don't remind me because I'll forget the next time. Tommy. I knew your last name was Lombardi.
Multiply 5.
Multiply by 5. Okay, I like it. Is that going to get everything away on the left side, though? What's going to remain on the left side if I just multiply by just 5? Isn't there going to be a negative sign still left by n?
Yes.
So if I want to get both of those to go away, what do you think I should multiply by? Negative 5. And that's what I'm going to do. Because I don't know about you guys, but I like doing less steps. I would have had to make this problem a 2-step problem if I wouldn't have done this. But let's just multiply by negative 5 and see what happens. So I've just got an n on the left side, and now we can say negative 3 and negative 5 make positive 15 when I'm multiplying them. Okay, maybe that shouldn't have worked. Maybe I should check my answer because I don't know. Maybe that was some weird thing that I just did that it wasn't allowed. Negative, and we got 15 over 5 is equal to negative 3. Does that check out? Yeah. 15 over 5 is 3. The negative sign was on the left. Now it's on the right as well. It does check out. Does that make sense? Okay, let's do another one. Now, this one is a little tricky. This is your problem number B, right? Problem letter B? Okay, good. This is a little tricky. Guys, what is pi? Right, so it's a number, right? Is pi a variable? No. What is the variable in this problem? X is the variable. X is the variable. So how do I move the stuff away from the variable?
Would you do division?
Right. Because it's pi times x. So I divide by pi over to the other side. Whenever I do division, I put it as a fraction bar. You can write the division symbol, but this is just what I do. I would suggest you do the same, so our work looks the same. Write a big horizontal line. Now, it cancels on the left side. What happens on the right side? Same thing, numerator to denominator.
You would just get negative 2.
Yeah, it just cancels and gets negative 2. So x is equal to negative 2 here as well. Yeah.
Could you write in 3.14 for pi?
Be careful with that. Leave it as the pi symbol. Yeah. Because whenever you change it, you risk rounding it. What do I do here? What do I do to solve this one? Top. Divide by what?
1.3.
Good. So z is equal to, we've got to take 5.2 divided by 1.3, and that gets us 4. Simple, right? Simple one-step equations. Add, subtract, multiply, divide. Let's do a couple more examples. This is on the top and the back. What do we do here to solve for y? Nathan?
Times 3.
Good. Multiply by 3. So y is equal to negative 6 times 3, negative 18. Good. Questions there? Yeah, Nathan.
So out of curiosity, so for example 2, A and
Yep.
1, I noticed that you could just multiply the total and then the denominator.
Yep, that works. Yeah, because that's really what you're doing. Multiply the equal to in the denominator. You're just getting the denominator over to the other side.
Will that work all the time?
Yeah, when it's left with just that, yeah. Yeah. Now, does it change anything when we go from fraction bar to division symbol?
No.
No. It's just another way to write divide. So what solves for z in number 2 here? Multiplication, right. Multiply by 25. Oh, not 2.5, 25. So I take negative 4.5 times 25, and I get negative 112.5. Negative 112.5. Oh, I forgot to put my big horizontal line there. And then my last one here for this set, 9 pi is equal to pi times x. 9 pi is equal to pi x. What do I do to get x alone? Sid.
I'm probably wrong, but I multiplied 3.14.
It's already multiplied. So instead of multiplying, what should I do? Divide. So I'm going to divide by pi. And again, instead of changing it to 3.14, look, it's going to cancel out right side and left side. So 9 is going to be equal to x. Yes. What's that? Oh, there's a number 4 down there. I'm sorry. There it is. I would have got it. So, the question on this one?
For
Last
number
one.
3.
Yeah.
So now I've noticed for the pi ones, the only number that's visible.
Yeah, those are just coincidences.
Okay, so that's not.
Be careful with that one too.
Okay.
0.05 W is equal to 1.4. What solves for W here? It's already multiplied, right? So it's division. So we take 1.4 divided by 0.05. Let's see what that is. 1.4 divided by 0.05, and I get 28. That seems weird. I got a bigger number. That's odd. Actually, it's even, but that's weird, right? So maybe it might be a good idea to check our answers. 0.05 times 28. Is that truly equal to 1.4? Let's check it. 0.05 times 28. Oh yeah, that is 1.4. I guess that checks out. So I do get a bigger number. That's totally okay. Whenever you divide by a small decimal, it actually increases the size of the number. Good. All right, questions about any of those simple equations? No? Okay, then let's talk about some word problems. Now, we're going to have word problems like throughout the entire year. And one of our goals, I was just talking with Mr. Delap the other day, one of our goals is to try to push you guys a little bit further into word problems because more often than not, those are the types of questions that you get on what's called your OST, your end of course test that the state has you take in April. So, what types of things can we do? Well, the first thing that we want to do is understand what's going on. Understand the problem. Figure out what's going on. Figure out what is known. Figure out what is unknown. Then make a plan to figure out how to solve the problem. Decide how you will solve the problem. Your plan might include one or more of the problem-solving strategies that we'll talk about in a second. We'll make an equation, all sorts of things. Then we solve and check. Now, we solve our equation and then check it to make sure that it's reasonable. I'm going to stress to you guys, make sure your answer is reasonable. There's always some times where I put a question on the test where I say, okay, the population is at 1,000 and it's going to grow to at a rate of this percent. And then somebody gives me an answer of like 50. Okay, if the population was at 1,000 and it's going to grow, does it make sense the answer got smaller?
No.
No, that doesn't make sense. Logically reason through that your answer makes sense. So how do we create those equations? Well, we can draw diagrams. We can write equations. We can look for patterns. We can work backward. We can guess. We can check. We can go back. We sketch. We make a table. We make a list. All sorts of things to do to create our equation to solve the problem. So, example 3 here. A discounted concert ticket is $14.50 less than the original ticket price. You pay $53 for a discounted ticket. What is the original price? Now, what I would like to do is figure out, what are we looking for? What is the unknown here?
The price you would have paid without the discount.
The original price. So what I'm going to do is I'm going to create a variable that represents my original price. Okay, let's make P mean my original price. I always like to define a variable. For word problems, I don't often use X. I try to make the variable mean what we're looking for. So P for original price. Now, can we create an equation that represents this situation? Well, let's read the first sentence. The discounted ticket is $14.50 less than the original. How do I represent just that phrase? Sid?
I wrote X instead of 2 by 6.
That's fine.
But then X minus 14.50.
Very good. And that's what I would say, just with a P instead of an X. Does it matter that you use a different variable? No, you use whatever you want. You do good. P minus $14.50, less than the original price, right? Minus $14.50 is equal to 53, because that's how much we paid. The original price minus the discount is the amount that we're paying. Okay, so perfect. We created an equation, and now all we have to do is solve it. What solves this equation? How do I solve this equation?
Plus 14.50. That equals 57.50. That would be the original price.
Very good. And I'm really glad that he went on to say, and that would be the original price. Guys, it's so important that you put your answer back into context. You know what I mean when I say that? Put it into context. Meaning, go back to the problem and describe what the answer means within the problem. Hey, if you can write a full sentence, go for it. The original price was $67.50. That's the answer, right? P equals 67.5 is not the answer to the problem. What was asked? What is the original price? That's what I want back out again. You know, we're not computers, we're people. We can put it back into context and really explain what it means. Here, on January 22nd, 1943, this is crazy. The temperature in Spearfish, South Dakota, at 9 a.m. was 54 degrees. And then at 9:27, 27 minutes later, was at negative 4 degrees. Crazy, right? So 54 degrees at 9 a.m. and then negative 4 at 9:27. How many degrees did the temperature fall? How many degrees did the temperature fall?
58.
58 degrees. How did you get 58 degrees?
Well, I basically turned the negative 4 into an absolute value.
I like that.
54 plus 4.
Good. He said, I see, okay, we got 54 degrees, and then it's going to go down 4 more degrees, right? Past 0. Here's how I would think about this problem. It's going to decrease all the way down to negative 4. That's the total amount of decrease, right? That's the total amount that the temperature is going to go down. It's going to go down from 54 all the way down to negative 4. Well, 54 minus a negative 4 gets us 58 degrees. Okay, so we can say, and how many degrees did the temperature fall? The temp fell, oops, I'm giving myself enough room. The temp fell 58 degrees. Did we necessarily need an equation for that one? No, we could just logically reason it through. It went down 54 degrees to go to 0. And then, like you said, absolute value, 4 more degrees down at the bottom there. It goes back into the negatives 4 more degrees. Okay. All right. I'm going to stop the video there. That's all we got for section 1-1.